Okay, so good evening everyone. My name is Andre Divanocha. I'm a board member at the Namibian Scientific Society. I'm also part of the astronomy working group at the society, where we try and do cool stuff with the night sky. Some of you might have seen our planetarium event. Some of you might have seen our recent event that we had with a telescope at Grove Mall. And so please, you'll see we're handing out a few flyers for our upcoming Southern Star Party. On that is a QR code for a WhatsApp channel, where if you scan it, then you can follow our channel where we post our activities like this. Obviously, I assume some of you are already following that because you are here, so very welcome to the Namibian Scientific Society. I don't think I have to give a big intro of what the society does, but the society obviously loves creating a platform where passionate people and knowledgeable people can share and connect with the society. And so from our side, Dr. Jani, we are very excited to have you here. And maybe also just on that note, a special thanks to the American Embassy, Ryan and George and Scott there at the back for collaborating with us on this. And yes, we're very excited for your talk. I'm just going to mention one or two more housekeeping things, and then I'll hand over to Ryan, who will also do something of an intro. So for us, it's been a privilege to have Dr. Jani here last year already, where she did a brilliant panel discussion at World Space Week, which happens every year in October. And then already she said she's coming back. And so we're so glad that you are back and that you are able to share with us what your mission is here in Namibia. And but earlier today, we had a bit of a roundtable discussion here in the hall with a few stakeholders, with a few other colleagues, discussing on how can we strengthen and work more together in the space sector. So there's really exciting things happening in Namibia. For example, in October this year, again, we're having a big event with World Space Week, where we're going to actually have an Artemis astronaut in Namibia, one that is shortlisted for the Artemis 4 mission to land on the moon. And so I don't know about you, but this might be just like meeting Neil Armstrong, you know, back in the day. So you have the opportunity, so please do follow our channel so that we can communicate that with you. I have a joke, if I may. I mean, Artemis is all about creating a base on the moon, and apparently they want to do a restaurant there as well. They say the food's going to be out of this world, but apparently the atmosphere is going to be a bit... I needed to work it in. I don't get a lot of opportunity for that. My apologies. Okay, so from a housekeeping perspective, there's a donation bar there at the back. I think everybody knows how that works. There's flyers being handed around for our Southern Star Party, which is in September. Please do follow that. If you don't have a flyer, we do have extra. And then just in terms of attendance register, we'll be passing that around. So please just fill in your details there. That helps us to get in touch with you. So I'll hand over to Ryan for further introduction.
Thank you, Zandri. That was a true space nerd joke. Can tell from the audience that it hit well, so we're in good company of fellow space nerds. My name is Ryan Bradeen, and I'm the Public Affairs Officer at the U.S. Embassy. And it's a great pleasure to be here tonight, and even greater pleasure to be here with Dr. Jani Radebaugh from Brigham Young University, who's doing some remarkable work here in Namibia that I think is surprising to everyone who learns about this, the linkage between the work that NASA's doing on this incredible upcoming space mission, the Dragonfly mission, and the role in which Namibia can play in that, and is playing in that. And not only through the geology and geography of Namibia, but through organizations like the Namibian Scientific Society. And I just wanted to really take this moment to thank Ruth and Sandre and everyone else involved in the Scientific Society, all of you, for just the remarkable place that you have in Namibian society. As the oldest NGO in the country, as a repository, one of the premier repositories of literature and scientific research, the role that this organization plays and that all of you play in Namibian society is really significant, and we greatly appreciate that. Such a reliable and valuable partner to us in this activity and many, many others across the years. And so it's really just a great pleasure to be able to have this opportunity to have an opportunity to hear from Jani. And so allow me to not stand in the way of that. We're just so pleased to have you and your family here with us again, Jani. It was a great pleasure last year. Had such a great impact that we're still reaping the benefits of even this afternoon. And I'm sure from today's presentation this evening, there'll be more unintended consequences that we can't wait to look forward to. So again, thank you so much for taking the time. She's on holiday, and so very gracious of her to donate a day of her time to be with us all here tonight. So thank you so much, Jani.
Right. Thank you, everyone, for coming tonight, and thank you, Ryan, for the generous introduction and for the great treatment I've had already here today. It's just been really wonderful. We're here on vacation, kind of. I have a conference in Swakopmund at the end of the week and some field work in Gobabeb that I'd like to talk about, but my family's here, and my niece and two nephews and my husband, and we had a great morning at Non-Kusei Cheetah Preserve. And if anybody, I mean, I'm sure you all know about this place, but it's really incredible. I got charged by a lion, so I think I'll never forget today. It's pretty great. So I would like to talk about some work that I'm doing as part of the Dragonfly mission to Saturn's moon Titan, and I'll talk about what that is. I'm a science team member, and we're doing some work here in Namibia that relates directly to that mission. And a lot of the work we're doing is at Gobabeb Research Station, so I'll talk about that and a little bit of detail about Gobabeb and what we're doing there. But I'll also highlight just a little bit of science that we're doing across Africa. Lots of different things are available to us here on this really great continent. So I will show some slides here. And I'd like to go back, yeah, nice. I'd like to go back to this idea that Zandre brought up about Artemis. Did everybody watch this Artemis 2 flyby? Wasn't that just spectacular? It was so incredible to watch those 4 people fly around the backside of the moon. We've not done that for a long time. We've not flown around the moon since 1972. And they did that in this really great capsule here. Incredible team, you probably can name them all. Here's this shot of their orbit. They looped in a wide orbit around the Earth, and then did you know this is how far they got? This is the distance between the Earth and the moon. And they even ended up going farther away from the Earth than anyone ever has before, because we flew kind of far away from the moon. I was a little disappointed by that. I'd have loved to skim across the surface, just like they could do during Apollo, and see things close up. But they were looking at the moon like it was a basketball held up in front of them, and then ended up coming right back to Earth. 4 days there and 4 days back. And boy, we were just on pins and needles the whole time, right? Wasn't that inspiring? It was so great. And they got pictures like this from their cameras. You know, we have pictures from orbiting spacecraft. We've been there for a long time with spacecraft, but there's something different about a person behind that camera taking the picture and knowing that somebody actually orchestrated that. You feel almost like it's you doing that when you think about that, which is really great. And they were really taken by this experience of seeing the sun go behind the moon. We get to experience that on Earth. It's kind of amazing that we can go and watch the sun get eclipsed by the moon. There's nothing that says the moon and the sun have to be the same size in the sky. And sometimes they're not. Sometimes the moon is a little bit closer to us so that we just get a ring of sun behind it. But sometimes they line up perfectly so that you see that corona pop up. Has anyone seen an eclipse before, a total solar eclipse? That's the most amazing sight I've ever seen in my life. So I highly recommend it. That day comes around, which it does. And so they were amazed by this. In this case, the sun was a little bit smaller behind the moon because they were so close to it. And it really reminded me of our days of exploration during Apollo, when we drove around on the moon with this great little buggy right here and explored and brought back hundreds of pounds of moon rocks so we could better understand our neighbor. And we did that during 6 different missions, 11, 12. Is that right? Everyone named them for me. 6 different missions, 12 people walked on the moon. But now we want to go back and live permanently on the moon. What are the benefits of doing this? Well, we can have a place to look at the stars without an atmosphere. That's a really big benefit. Those space telescopes are able to see a lot for us. We could build an even bigger one if we just have the surface of the moon to put that on. Maybe we could build rockets on the moon and launch them directly into deep space from the moon so we don't have to worry about the Earth's big gravity. And for me, this is just pure exploration. We get to explore another portion of the solar system that we don't know much about. We've only been to 6 different places, and they were all close together on the near side. We want to put our base on the South Pole so we can access some water that's sheltered away in craters, and so we can have 24-hour daylight to power our solar panels. So this is in motion. This is Artemis, and hopefully we will have people on the moon in 2028. This is what NASA really wants, and they're working hard toward that. So NASA wants every nation involved, and we would really love that. Here, 6 African nations have joined this Artemis Accords program, and that's hopefully growing. So here's our beautiful moon, and this is a picture taken from my university campus by some astronomers there, Brigham Young University in Utah in the western US. And what I love is that you can see lots of giant long rays coming out of fresh impact craters from things smashing into the surface. And then the large dark patches you're familiar with when you look up in the night sky, these are lava-filled basins. Big, huge ponds of lava filled up these giant impact craters and then since then cooled down. So the moon has been cold and dead for quite some time. Imagine if you had this in the night sky instead. This is the same size as Earth's moon, but it is quite different, isn't it? This is Jupiter's moon Io, and because it's orbiting so close to Jupiter, the tidal forces keep the inside, they exert friction on the rocks, and that causes heating and melting. And so there are hundreds of active volcanoes at any one time. So all the dark spots you see are erupting volcanoes, and then there's lots and lots of, can you guess what the yellow must be? Sulfur. Sulfur everywhere. It would smell like rotten eggs, which is my favorite smell because I know I'm near a volcano if I smell that. This is what it looks like at night. This is from a mission orbiting Jupiter now called Juno. And in the infrared, we can look and see dozens of actively erupting hotspots on Io at night. And I've been working with some people on the Juno mission to try to better understand these volcanic eruptions on Io. And we would love to send a whole new mission there to better understand what's going on. We think a lot of the eruptions are in lakes of lava. So you see the kind of shiny surfaces here in the foreground. Those are recently cooled lakes of lava, kind of like when you're flying over the landscape in an airplane and water lakes shine at you because of the sunlight. The same thing's happening here. And what would that look like? Do we have any lakes of lava? We do. This one's in Ethiopia. Where is it? Oops. Yeah, there's the picture. I'll go back to the video. And this one is absolutely beautiful. Do we have, oh, he's gonna help me. This is a picture I found online, and he just goes by Colin. So I said, Colin, can I use your picture? He said, yep, just say Urta by Colin. So there it is. But this is a really neat thing to visit. And it is, oh, I don't know if I can go backwards. We'll try right here. It's, oh, sorry. Go back one. Oh, there it is. Okay. Maybe go back one more. Yeah, one more back, and now forward. So now leave it. I bet it'll go. Maybe. That's fine. Try one more. There we go. Okay. Notice that this is almost like, do you remember seeing those maps of the Earth's plates and they're spreading apart from each other? This is sort of like a thin skin of lava.
The connection for the stream.
Oh, sorry. Oh, I see that. Okay. Okay. And every time that happened, I could feel a wave of heat and I'd start coughing. It's really beautiful, but look how fast it cools off too, which is always so amazing. And this took a long hike up in the dark because it was 100 degrees. Well, let's see, what was that, 40 degrees? And so we had to wait for nightfall. And boy, my guide was just cruising up the hill, and I thought, I wish he would slow down for me. And then I saw him the next morning, he was 15 years old. So, okay, let's see. We'll just go to the next. Okay. Oops, is that okay? We just move on? Yeah, okay. So yeah, this is what it looks like at night, and it's beautiful. And we can study this up close and better understand the lakes of lava on Io. So that's what we try to do. We find places on Earth that are like what we see on other planets, because we can walk up to this one, we can look at it in detail close up and compare it with our orbiting or landed spacecraft on other bodies. Here's another region near Urta Ale. This is in northeastern Ethiopia, and this is called the Dalal. And this reminded me of Io again because of all the yellow from the sulfur, and there are greens, and there's also salt underneath all of it. And this basin is slowly opening up, and one day will be its own volcano. So we return to Ethiopia when we can, and sometimes my friends put me on the surface too, my artist friends. So this is me on Io, but it's really Ethiopia. Okay, we're going to keep on going out in the solar system. At Jupiter, we were 5 times as far away from the sun as the Earth. Now at Saturn, we are 10 times as far away from the sun as the Earth. And you remember how far the moon was from the Earth. Well, that's just tiny compared to how far away we are in this case. This picture looks just a little bit fuzzy, maybe, but this was taken through a telescope in the backyard. This is by Clyde Foster, who lives up on the mountain, and he works at Hess. And I saw many of you have got the flyer for Hess. Please go visit that extraordinary facility. And he's an amateur astronomer who actually worked to observe Jupiter back during that same mission, Juno, that I showed you before. And he found a storm on Jupiter that they subsequently saw right after that with Juno. And this is called Clyde's Spot. And the Juno mission recognized that and spoke about him. So it's really, really wonderful that he managed to make that great discovery. So here's his picture of Saturn, and look how clearly you can see the rings, and you see the gap between the rings. That's called the Cassini gap, named for the scientist who first saw it. And you can also see the lovely bands of color, and then we can also see a couple of moons back here. And Saturn has some really extraordinary moons, and I'll talk about one of them in just a minute. But we'll show you this other one taken a little closer up. This is by the Cassini mission. And that was in orbit from 1995 until 2000, no, that was Galileo. This one was 2004 until 2017. Orbiting Saturn, taking these beautiful pictures of the nice soft atmosphere and the severe rings. The rings are very thin. They're 100,000 kilometers across and just 1 kilometer high at the most. And so they're blade thin, and you can see the shadow of the sun cast across the rings right here. And so Cassini was a really valuable mission because of what it told us about all these moons of Saturn and Saturn itself. This was run from Jet Propulsion Laboratory in Pasadena. And many of you know about Jakob von Ziel. He's a scientist who ended up being head of the Science Mission Directorate at JPL. And JPL is in charge of lots and lots of really valuable space missions, notably the Mars rovers that you've probably heard about or seen pictures from. And Jakob was intimately involved in those missions and was in charge also in part of Cassini. So here's a picture of him. We all think he was slated to be the director of JPL in the future, but he passed away early. But really did a great service to Namibia, being from here. And it turns out, I didn't know this, but he named a bunch of features on Mars after Namibia. So kind of sneaked those things in. I think that's great. I love it. Okay. Well, so my favorite moon of Saturn is called Titan, and it's quite big. It's actually bigger than the planet Mercury, much bigger than the moon, not quite as big as Mars, which is half the size of Earth. But notice this, when you fly over again in a spacecraft, there's something that is reflecting off the surface, and there's also something hazy. So 2 things are apparent here. The first is there's an atmosphere at Titan, and the second is that there must be liquid on the surface that's reflecting the sunlight. And that's true. And I'll show you that picture in just a minute. There are lakes and seas of methane across Titan because it is so cold. So here's a picture of where Titan sits compared with Mars and Mercury, and then Earth and Venus. And the neat thing about Titan is that the atmosphere has the same pressure as Earth's at the surface. And that's a strange thing. Once again, it didn't have to be true. But it just happened to be that it's the same pressure. So if you visited Titan, you wouldn't need a spacesuit. you wouldn't need a pressure suit at least. You would need something to keep you very warm because it's really cold there. But you wouldn't need a big bulky pressure suit like you do on the moon or in space. It's got gravity that's about like the Earth's moon, so that makes it easy to move around on Titan. And oh yeah, so here's a picture of these pressures. These are the spacesuits that you would need on Titan. There's an artist rendition. They don't look like they're much. But we do have to think about the fact that the atmosphere is at least a little bit different in composition. So I don't know if any of you saw Project Hail Mary yet. It's a pretty great movie. And yeah, as you know, Rocky had to put himself in a much different atmosphere than, what was his name? Than the main guy, Ben, or whatever. And so we have to, thank you. Ryland Grace. So we have to contend with that when we explore other bodies. Thank you. Okay, well, here's a picture that we took from Cassini, and we used a different instrument. It's called radar, so it could see through the atmosphere. So sometimes they're like a black and white picture, which we colorized here, so that the bright features are rough and the dark are smooth. And it's hard to find out what else would be quite so smooth and shaped like this than a lake. But we already said it's really cold. It's way out at Saturn, so water is frozen solid like a rock, and instead it's methane that is liquid, and it forms clouds and rain and rivers and lakes and seas. Lakes of methane all across Titan. And that's a really crazy thing because we don't have lakes or rivers anywhere else besides Earth and Titan. The other thing that exists in great abundance across the equator, where the deserts are sand dunes. And again, this picture is radar, so it shows the sand dunes as being dark, which is the same thing for Earth sand dunes. But these are also a little bit brownish in color for the couple of images we have of the dunes. And they're very long and straight. In this picture, each one of these is spaced by about 1 kilometer. So that's a lot of distance that they're covering. It turns out, so we realized that at the time when we said we should go visit some sand dunes. So here I am in Algeria. Promised I would talk about other parts of Africa. Here's a nice video that Bryce took up on the top of a really large sand dune looking out across a vast sand sea that's about 500 kilometers from this point to the other edge of it. And we have a couple of sand seas on Earth. This is one. But it turns out that the Namib Sand Sea has dunes exactly like those on Titan. The same size, the same shape, and the same interaction with obstacles. And we knew that because we just started looking at Earth images. As soon as we saw these beautiful Cassini images, we said, where else can we go on Earth? This is Cassini on the right of Titan. Where else can we go on Earth to find something the same? And it turned out to be Namibia. So we've been looking at this location for quite a while now, ever since Cassini first arrived. So in this picture right here, we can see a big impact crater from when something smashed into the surface and melted water ice that formed the bedrock and created a big ejecta blanket, like what we saw on the moon. Something else that's pretty neat about Namibia is there is an impact crater in the south called Rotor Cam, and we visited that in 2013. And that is also filled with sand, just like something like this is filled with sand dunes right here on Titan. So again, it's another place we can go and study Titan in Namibia. This picture will show a little bit of what I'm going to talk about. So the G at the top is Gobabeb Research Station. Has anybody been there before? It's a really great place. I'll try to prove to you that you should go visit Gobabeb, even on your vacation. So here it is, and then we went to Site 1 in our trucks, south of Gobabeb, Site 2 in our trucks, and eventually we drove around to Site 3, which is Sassusvlei. Probably a lot of you have been there. And then this white path is the beautiful flight path you can take if you take an aircraft from Swakopmund and fly across the Sand Sea, and that's another really strong recommend. Okay, so here's a picture from that overflight, and you can see just miles and miles of dunes. So there are a couple of really big ones right here, kind of horizontal to the picture, and a couple of little ones that are streaming off to the side as well. And then some of the spaces between the dunes can be a little bit sandy as well. Well, why is that true? Why do we have so much sand in Namibia, and why is it so perfectly analogous to Titan? And I think a couple of things are going for it. The first is that we're sitting at a great latitude right down here. This is the desert on this side over here because of the wind patterns, the global wind patterns. So it's helping create a desert plus the latitude. And then the Orange River from the south is carrying a whole bunch of sand out that gets dumped into the ocean and then is transported by what we say this marine conveyor of currents that are coming up from the south, and then they spill the sand back out onto the continent. And then the wind helps to trap it and keep it in this perfect, beautiful sand sea. Now we're looking toward the south here. And then also we've got some land right here, the Great Escarpment, that helps to trap it. So this sand has been here for many thousands of years, and it is recycled. It's been sand dunes. They've been solidified. They've been recycled and re-input into the system for a long, long time. And there aren't many other places that are like that in the world where we can keep the sand. So here's a close-up view of the Namibia dunes in radar on the Earth, and you can see that they're dark in color again, except where the light shines on them, and this is radar light, and it's kind of shining off of the crest line so you can see it. And you see lots of diversity in the dunes. They're kind of sweeping around these rough and bright mountains right here, and but they're very straight and parallel to each other. And so we've been saying for quite some time in our papers that these are just like dunes in Namibia. So we should go and study them. And we did a field trip in 2013 where we kind of put the idea together to bring a lot more people to see this location. And I always tell people, just to give you a sense of how big these dunes are, these trees at the bottom are tree-sized. So that's how big they are. Okay. Well, we did a field trip here last October. I got a group of 40 people to come. It was a NASA-funded research project just to bring people and immerse them in this environment in the Sand Sea. The beauty of Gobabeb is its position on the north end of the Sand Sea. Here's a Koiseb River right here, which is mostly dry, and you drive across the river and up onto the dunes, and you can venture down into the Sand Sea. Here you can see a little video. There's a road off to the right to show you some scale. Notice there are some bushes here. There's some vegetation. And so there's some game present. You can see, we found a little tiny baby springbok last time. And you can see other game in between. And there are some other wildlife, little kit foxes and some beetles and other things there as well. There's a great facility here where you can meet. And every night we would collect together and discuss our findings for the day. And just experience the environment, which is so pretty. This is my Indiana Jones picture off to the right. Isn't that great? Facilities are good. Here's my advertisement. So here's the villa. Villa's great. And then some beds right here. There's Wi-Fi. Meals are provided. It's all really good. And great scientists are involved in making this a good research venue for lots of people worldwide that come out to study here. There's, of course, great adventures for your students to have right here when you bring them to. And here's some of the wildlife we see. They take you right out on the dunes, and we try to preserve the really sensitive areas. We either stay in the tracks or else go places where the sand will move and cover up the tracks. And that works out really well. When we went in 2013, we brought with us this instrument. It's called a ground penetrating radar. And so I talked about radar before. That's from the air. And it sends a signal to the surface and shows us a picture. In this case, we're taking a picture down into the subsurface, and we want to understand the layering of the sand dunes. That will tell us something about which way the wind is blowing over time, and also which way the dunes are migrating. Because they're so big, it's really hard for us to watch them move over time. And so we really need to have something to tell us in the subsurface what's going on. And we had a couple of Gobabeb scientists working with us. Titus Shuya and Theo Wassenaar were helping us at the time, and my two students. So it took us all day to get to the top of the sand dune, just once, but it was worth it. Look at that at the very crest line. And once we got to the top, we got really beautiful data. This is some of the best that the scientist that helped me process this data at BYU says he's ever seen. And that showed us, we've got some sand in layers up here, but we've got some old swooping kind of truncated layers that shows a really complex history in the past. And it shows that sand is moving down the dune long axis. And that's a little different from other kinds of dunes where it moves across the dune or transverse to the dune. And so these are just really long, really big forms that take a long time to change and to move. Here we are here. We love this picture too. Here we've got Theo looking at us. Another thing we did is we drilled down. Let's see if I've got that data. Oh, I might not have put it in. We dug some holes and took a little sample right here to tell us how long since the sand had overturned last. And up on the dune, we couldn't ever get an age. Just tells us that sand overturns quite a lot, and it's young. But down here in the space between the dunes, this surface tends to be really old. It was many thousands of years old, 14,000 years since that had overturned. So that just also tells us the dunes move almost like a paint on the top of an old surface. And it's really neat to quantify that. Okay, well, one thing that we think is really helpful is that in Namibia, we can actually figure out wind direction and strength over time. We can tell the winds are blowing around these obstacles right here and forming a teardrop pattern. Most of the time, the winter winds that come from the north end up helping to shape the dunes. And so we can apply those findings to Titan and say, okay, well, so then our wind directions must also come basically from the right to the left in this picture. And that helps us figure out wind direction for Titan. And actually that's backwards, it's from the left to the right, all across Titan. Well, wouldn't it be great if we could actually just fly and land among the dunes of Titan ourselves and be there in person just like we can be in Namibia? So we have a mission, and this is Dragonfly. And this is what it will do. It'll come down through the atmosphere. It's a drone. It will just detach from the spacecraft and it will fly. And this background was made and designed after Namibia. It will fly across the dunes and then land in the space between the dunes and do lots of studies. Here's our power, here's our antenna, and then it will pick up and fly again to the next location. So it's really exciting, right? It's an incredible mission. It's big. Look how big it is. There's a model of it with me standing next to it. It's sitting on the ground. It's as tall as I am. So even though it's a drone, it's basically, we call it a rotorcraft lander because it's mostly a lander, but it's able to pick up and fly. It's kind of like the Mars rovers, but it's sort of even better because we can fly much farther than those can. It will investigate the surface and the atmosphere, and it will drill down into the subsurface. We'll talk more about that. It is being assembled right now. It is being assembled. It's being put together, and it will launch 2 years from 2 days ago, 3 days ago, July 5th, 2028, 12:05 p.m. So we can all wait and watch. It'll be really wonderful. Okay, well, it's got a drill on the leg. Look at this. It drills right down into the subsurface and draws material up into the spacecraft. And it will go into an instrument that's able to split everything up into its numbers of atoms. This is called a mass spectrometer. And the numbers of atoms will tell us what it's made of. Something I didn't mention yet is that there are lots and lots of materials on the surface of Titan that are organic in composition. This just means that carbon and hydrogen are involved, and you can see one of those molecules there. Carbon and hydrogen, it doesn't mean that life made it, but it is the same kinds of materials that life could use if life were there. And that's all just sitting on the surface, and that includes the sand dunes. We can look for things like what we call chirality, and life on the Earth prefers a certain handedness of certain molecules. And if we were to find a preferred number of right or left-handed of those kinds of molecules, then we might be able to say something is organizing that on the surface. If they were 50-50, it might just be random chemistry. And so that's one way we can test not only for the right ingredients for life, but also maybe some evidence of life. And remember, we don't have evidence of life outside of Earth. We only have it for Earth. And so NASA is really looking hard to see if we have evidence of life elsewhere. Could it have started somewhere else? Seems to make sense, but we just haven't seen it, right? Okay. Well, so we have a couple of other things. We've got some cameras. Look at the cute little face right here, a couple of eyes. And we've got another spectrometer, a couple of those. A seismometer, so we'll lower something down onto the surface and listen for Titan quakes and maybe get a sense of where there might be liquid on the seafloor, which would be really great. And so we are going to land right here. This is what's called the landing ellipse. We will land somewhere in that red box, red circle. This is underneath a crater, another impact crater. And on Titan, since the crust is water ice, the crater would have excavated a bunch of water and melted it and placed it in contact with all the organic materials. And so now you have water, you have organics, and then energy from sunlight or from chemical reactions, and those are all the right ingredients for life. Okay, but we're landing among the sand dunes. We need to be able to communicate with Earth, and the deserts are at the equator, and so we've got to look directly at Earth at the equator, so we get to land in the sand dunes. I'm very excited about that. So that's part of why we brought this field trip back to Gobabeb in 2025, and here I have a bunch of Dragonfly leadership and engineers and some science team members, plus just scientists from the US. We were restricted to US participants for that grant, unfortunately, but we would love to run up other field trips with international participants, and especially Namibians in the future, aside from Eugene at Gobabeb, who helped us out. So we really enjoyed this. These are actually the dunes south of Swakopmund. We were able to walk everybody up the crest. That was my #1 goal, to help everybody see how big these dunes are, right? How long does it take you to walk up to the top? And now picture yourself as Dragonfly flying around in this landscape. Getting a sense of the differences in the materials here. The gravels are very different from the sand that's piled up into the dunes. We got to do an overflight, that same path that I showed you, because we want to see the perspective of the landscape from what Dragonfly will see from that perspective. And I really loved being able to fly over Dead Vley and Big Daddy, because we did hike up that later on. And we looked over on the side and thought, oh, what is this strange pattern? Could we go look at it? And we did. We got to go see that later. And it's actually a piece of an old interdune, the space between the dune. And it was eroded away so that we could see the side of it, the cross-section of it, and that was really valuable. There's lots and lots of clay with little polygons exposed right here. It was great to just help everybody drive across Namibia and get that experience, and be able to stop at some other areas. Some other scientists had thought about that as a Titan riverbed analog. So not only do we have dunes like Titan's dunes, but we have riverbeds that are mostly dry, just like Titan's riverbeds, and that was really great. This is the mission leader, Elizabeth Turtle at Johns Hopkins University Applied Physics Lab, and she was there, and the lead engineer was there as well, so that was really great. And then I just wanted a picture of Dead Vley in there, because I really think it's so pretty. And I wanted this picture. There's nowhere on Earth that's like this. Don't you love it when you find it in the movies? How about Dune 2? You saw that scene in Dune, and you knew that it was Namibia, and there's nowhere else to film that but here, right where the dunes meet the ocean, and that's a spectacular location. Every day we would drive south of Gobabeb 10 kilometers. We got stuck quite a good number of times, which is also good for people. And then here's Eugene Marais, who's the second lead scientist at Gobabeb, and who came out with us every day and helped us do our tasks. And there were a number of things that happened. Here we're taking an instrument that's just like the drill and drawing materials up using a vacuum, just like what will happen with Dragonfly. So here's an engineer from Honeybee Robotics who came along. We were looking at the grains, because we're going to have a little imager on Dragonfly so we can look at the sand grain sizes. These instruments here are just like a different the neutron spectrometer that we'll have on board, and it sees into the subsurface and tries to find water down there. And here we're flying a drone to try to see the change that's happening in the dunes over time. Sorry for the snake. That's fun though. And then we also measured things like, here's an engineer, Carolyn. What are the angles of the surface? Because we don't want to go above 10 degrees with Dragonfly. We don't want to risk tipping over, right? There's nothing to help us tip right back up again. And what she found is most surfaces are great. There's just the very top that we want to avoid. But you can still land on the side of the dune and be okay. And actually, my best moment was when the lead engineer came out of his car when we first arrived and put his hands on his hips. He's like, oh, we can do this. I was like, oh, okay, good. Glad. We enjoyed just looking at the differences in lighting. And so notice in this panorama view, when the sun is shining this way, everything looks nice and red or white. And when the sun is shining toward you, you just see shadows and brightness. And you also can see just how big the space is between the dunes in this massive sand sea. Here's another image of that. So this is the same view. I hope I can convince you. The same dune. In the first one, we're looking toward the sun. In the second one, the sun is behind us. And look how different the color is. We really got fooled because at the top of a dune, we said, oh, the interdune over in this direction is dark and the interdune in the other direction is bright. But in both cases, they were bright. It's just we were seeing shadows in one of them. So we always have to be careful, especially in deserts where we don't have anything to anchor us or any sense of scale. It's hard for us to be sure what we're looking at. We also placed these wind meters up and measured the speed of the wind. And at this one right here, we could see a lot of change over the course of about 28 hours, where it really would speed up at night. I noticed every night. That was kind of neat to see and then to measure. And so we expect the wind speed to be much higher at the crest of the dunes, and that would be good for Dragonfly to know as well. And then we just got some beautiful videos overhead. The green star is showing a dune-heavy region of the landing ellipse, which is exactly what we're showing here. And you can see a road right here. We're at the point really close to Gobabeb. You can actually walk here. I think we got this video after walking over from Gobabeb. And notice just how varied the landscape is, how many dunes there are. It's amazing. And then if we go to a region far south of Gobabeb here, these are trucks down at the bottom, and notice just how wide open and flat the space is, how free of dunes it is. There are just a couple of little tiny ones, but there are big regions of our landing ellipse that have that kind of spacing of dunes, and so we might spend some time without seeing any dunes at all. And we would love to come back and study these rivers in association with the dunes again. So there's still lots of work for us to think about in the sand sea. Okay, I just loved being out with everybody and exploring and driving in the dunes. I guess I'm not driving, I'm filming. Riding along with Eugene, it was really great. And we'd drive up ahead and then somebody'd radio, oh, we're stuck. We'd drive around again and get the ladders out, dig underneath, put the ladders, push the car, get it out, get in the car and drive ahead again. Oh, now we're stuck. This happened probably 20 times in one day, but it was great. It was a lot of fun. And so really our conclusion is that Gobabeb is essential for this NASA mission, Dragonfly, because Namibia has these identical dunes to those of Titan. The organization and resources of Gobabeb is really enabling. It helps NASA scientists and engineers to experience Titan on Earth, and that's really valuable, right? And Namibia and Gobabeb are really helping us prepare to explore the outer solar system. All right, thank you.
Jock, I don't know, do we have an extra mic for questions and answers, or do we just use this one? Only this one. So, Dr. Jani, that was amazing. Is there any questions for her? Then I can maybe pass the mic around. Okay, let's go.
Amazing talk. Thank you so much. Are the scale of the Namib dunes compared to Titan's dunes? Obviously, Titan's got I assume, much less gravity than Earth, although it's the same atmospheric pressure. But what do we see in terms of scale difference between the two?
Yes, oh yeah. So great question. What's the difference in scale? And it's so strange that we looked and said, oh, they're the exact same size. You know, if we measure them, they're a couple kilometers apart from each other. They're a kilometer wide, hundreds of kilometers long. And often we'll have, oh, we've got a volcano on Mars. It looks just like a volcano on Earth, only it's 10 times bigger. There's usually some kind of difference like that. So the reason for this, we think, is that first of all, the pressure of the atmosphere is the same as Earth's at the surface. And so we think that boundary layer effect of the wind on the particles is really similar to Earth's. But you're right, now we have lower gravity. Why aren't they bigger? And in this case, the winds are lower. So the wind speed is only about a meter a second, and it gets much faster than that on Earth. So you only need that meter a second wind, and with the low gravity, with the atmospheric pressure, and we even factor in density. The atmosphere is a little more dense on Titan than on Earth. All of those together means that the sand is about the same size as sand on Earth, and the dunes are the same size. So there's still some unknowns, but we think those are the main reasons. Yeah. Thanks.
I'm curious, you mentioned that you want to study how the dunes move. Is there Google Earth images that can be, I'm sure you've probably looked at that before.
So yeah, can we use Google Earth to see the dunes moving? And the answer is yes, especially for little tiny, we call them Barken dunes, they're like crescents. Those move really quickly. They move maybe 10 meters a year. They just rip along. But these large dunes, what I've noticed in the amount of time that we've had good enough resolution, the base of the dune does not move. And so I have a track of me walking along in 2013, and it's in exactly the same spot. But the crest line can shift around by tens of meters. But it seems like it shifts here and then it shifts here. But we need to watch longer to know this. And these are the unanswered questions that we're hoping our kind of dune community can keep working on. This meeting that we're going to in Swakopmund, they're all the world's experts in dune dynamics and dune motion. And we're still working through these questions for this kind of dune, which is fun. Yeah.
Thank you, brilliant talk. I have two questions. So the first is, so I assume Dragonfly would be flown remotely. How does that look like? What goes into like flying something that is so far away remotely? And then the second question is, so what does a successful mission look like?
Yes, very good question. So the first is, we must have to fly it remotely because Saturn is so far away from the Earth, and it turns out it is 1.5 hours away in light travel time. So that means that if we send a signal, and that goes at the speed of light, we send a signal to Titan, it takes 1.5 hours. And then if Titan wants to communicate back to us, it takes 1.5 hours. And so there's no way we can fly it in real time. It has to be automated, and it has to be autonomous. So there are landing sensors to be able to tell, oh, no, we're close to the ground, so slow down the propeller speed. Okay, you've landed. So all of those things will happen without us knowing. Well, 1.5 hours later, we'll say, oh, it made it. We won't even know. So that is one challenge, and we just need to make sure that we're as safe as we can. The biggest, I think, nail biter is as it gets released, and then it needs to land in a safe spot. Once it does that, the next time we'll pick up and we'll fly around and kind of scout and then come back to where we were. And then we'll know the next safe landing spot. We can talk about that for weeks, and then we can go to that next spot. So all we need to do is land and take data with all the instruments. Then we need to fly and land again at a different type of location. So not this space between the dunes, but a different space between the dunes. Take measurements there, and then that's mission success at that point. What we hope, and in fact it's designed to do, is to operate for 3 years. And so we should be able to, we really want to get through the dune field up to the impact crater and look at that interaction of water with the sand. That would be great.
Well, in your exploration, how is it that you chose Titan and not another moon, or why the moon of Saturn and so far away?
Yes, very good question. Why Titan in the first place? One of the biggest goals of NASA right now is to find if there's been life on another body. And so we do spend a lot of time on Mars because Mars has a lot of possibility for life. It's Earth-like in many ways. It's just a little farther away from the sun, so it's quite a bit colder. It's never warmer than Antarctica on Mars at any time. And we've maybe found some evidence that there could have been life. There are a couple of little things that could have been fossils with the most recent rover. We need to bring those samples back to test them to know for sure. The other places we can look for evidence of life are farther out in the solar system where there's lots of water. And those are the moons of the big giant planets. We would love to know a little bit more about Saturn and about Jupiter and send some probes into the interior, but they don't have any possibility for life. The interiors are too hot, too high pressure. But Jupiter has a moon called Europa that has a icy crust and a liquid water ocean, and there's a spacecraft going there. It's called Europa Clipper. It will orbit Jupiter and look carefully at Europa. But we can't land yet. We don't have that technology. So we need to develop that technology to land and maybe drill and swim around. That would be great. So Europa is a possibility. But Titan is easy because all of those organic processes are happening right on the surface. And we already have that technology in this drone. And we can just fly and land and analyze it right there. And to me, if we only land and we just pick it up and look at it, for me, the sand at least, then I'm satisfied because we don't know. We don't know what it is. There are lots of unknowns about it.
Thank you for a very, very interesting talk. I have a few questions. The first is, to what extent did learnings from Mars Ingenuity inform the engineering of Dragonfly? Second question would be, to what extent, so you mentioned that there'd be 7 cameras on Dragonfly. To what extent, from a remote sensing perspective, what are you hoping to gain in that regard? And then my third question is, has any form of elevation modeling been done on Titan? I'm not sure the extent of remote sensing that's been applied to Titan, but do you have, is there any kind of elevation model? Yeah.
All right, thank you. Great question. So first of all, we've had a helicopter or a drone on another body already, and that's called Ingenuity. It's a tiny little helicopter that was released in the last Mars rover. And that's astonishing because at Mars, the atmospheric pressure is so low, it's 1,000th that of Earth's 100th. 1/100th, but so if you take your spacesuit off, then you'll explode. I guess that's not a very nice thing. Anyway, so you want to keep your spacesuit on. And that makes it very difficult to fly. So if what we had to do with that helicopter is the blades had to be very long, from me to the wall, and then spin it 2,500 times per second? Maybe it was minute. Minute, okay. So very fast rotation speeds, and then they could only hold a little tiny payload. But it was amazing. It flew 72 times and got lots of pictures. It got pictures of the rover from overhead. It was really valuable and a great test of technology. And they're getting ready to send a fleet of a few more of them to Mars to do some more science. So that was really great. I think they actually slid that in sort of underneath. So Dragonfly was selected already, and then Ingenuity was sort of put on board Perseverance. And so it didn't really directly affect it. However, JPL people are working on Dragonfly, and so I'm sure there's some lessons learned. And we try to do that with each other, do lessons learned. Your second question was about, I'm going to answer your third one because I remember it, and it was about, what kind of pictures are going to come back from Dragonfly? And one thing that's difficult for us is we're used to Mars, where we have all these orbiting spacecraft, or the moon, where we can just beam data up to those orbiters, and then they can really send it down like a fire hose to our radio telescopes. But tiny little Dragonfly is going to have an antenna this big, 10 times as far away from the sun as the Earth, and so it will send a little trickle of data back. So we have to pick and choose what kinds of images we want to send back. And that will be so hard. By that point, I mean, you'll have video, I don't know, drilled into your eyeball that you can, like it'll be hard to comprehend a world without streaming video. And this will still just be pictures, and not very many of them. But we should have enough to be able to see a lot of the same kinds of landscapes I showed here. Maybe not quite as detailed, but really similar, and then some close-up images as well. We have a couple of elevation models of parts of Titan from Cassini, but our image resolution was not very good. 150 meters per pixel is all, so not great.
I have 2 questions. The first one is, what is the percentage of the accuracy rate like of the data being sent to Earth? Like there must be like some certain factors which might corrupt the data which is being sent. And my second question is that I'm still confused. Like, how is like the drone able to fly like on on the or like in the atmosphere of the planet?
Good questions. It's important to think about how our data gets back and how that's being transmitted. If the data gets sent, they're sent to really large radio telescopes, and they're very good at capturing everything that we're, as long as we're pointed in the right direction. If it's not pointed in the right direction, if something affects the data, then we know it on the ground, and we can say, oh, this is corrupted. Can you send it again? And so we'll ask to send it again until we get all of the data, until it fills in correctly. And then we know that we have confidence in the data that we have back. And then the question is, how do we fly around? We've got this thick atmosphere. One thing I forgot to mention, it's nitrogen, just like Earth's, right? The dominant constituent of Earth's atmosphere is nitrogen, 70%, and then 25% oxygen, close to 30. And on Titan, it's almost 95% nitrogen. It's a very stable gas, and we'll just spin the rotors and it will fly no problem. It's got a lower gravity, and it should work really well.
Yeah, gravity was one of my questions, but is there a magnetic field? Are there poles? And how does the planet influence the navigation on the moon?
Good question. So there is not a magnetic field, and that does make challenges. Mars also doesn't have a magnetic field. And so if you're trying to navigate there, you have to use other things. You can use inertial reference frames where you start knowing where you are, and then using inertia on your spacecraft to tell you where you've gone since then. But you have to establish that reference point first. And I've heard them talking about that for Dragonfly, and I'm not sure, I didn't follow exactly what they said they would do, but they can, after spinning the spacecraft around a couple times, figure out where they are in space according to north-south. There are poles because the body spins, and so it's a physical north-south axis, an axis that goes through Titan, and then it spins around that. As it goes around Saturn, it keeps the same face pointed toward Saturn, but it spins with respect to the sun. And so we will want to know where it is compared to north, and it'll be able to figure that out, but it will take a little while because of no magnetic field. We're lucky on Earth. We're so lucky on Earth to have many things, and one of them is a magnetic field that not only helps us with direction, but it protects us. It protects life from the solar wind, and our atmosphere protects life from the solar wind. So all the things were just right on Earth for life, which is good for us. Just not magnetic poles, but there is a north-south pole because it's spinning. And so, if you think of it as, if you're standing on the North Pole, you can just move your feet around and the planet spins under you. And that's how it will be on, it's how it is on Titan as well. Yeah.
Ma'am, thank you very much for your time and presentation, which is excellent. About 10 years ago, I went to a presentation in DC at the Foreign Service Institute, and one of the astronauts spoke, and he said something that stuck with me the entire time since then. And he said that the Mars rover is powered by nuclear power, right? His main concern was that he stated, I believe this was Senator Mark Kelly back when he was an astronaut, if I'm not mistaken, and he said that he knew that there were bodies of water on Mars, but that if he got close to them, that there was a concern that they would be contaminated by the nuclear powered on the Mars rover. Has that technology improved? And is that going to be the same type of power that's going to be powering these drones and other rovers in other locations?
Great question. So yeah, I think Mars is an interesting place because there are a couple of what we call sensitive regions, because it looks like some gullies formed and that water flowed down them. We can see change over time in them. Best explanation is that water melts during certain seasons and it flows down those gullies. Wouldn't that be a great place to go and look for evidence of life on Mars? But we're not allowed to go there because they're sensitive. What if we go and we contaminate it with our own life that we brought with us? And a good example of that is we went back with one of the Apollo missions, and and found a Ranger spacecraft that was 3 years old and sponged off a little bit from the side, and there was living bacteria on the side of that that had lived for 3 years on the moon and in a vacuum, and in freezing cold. So life is really resilient, and we have to do things called planetary protection when we go to those places. We don't have to do any of that for Titan, which is really shocking. But Titan is so cold that absolutely no life that we can imagine here can live there. So we don't have to clean our spacecraft at all. Anything we bring there will be killed instantly, without question. It's too cold. Even like way colder than the moon in those parts of the moon. So we don't need to worry about the plutonium contaminating those regions. But nuclear power really is a legitimate way for us to get in different parts of the solar system and to live for a long time. And so we'll have to continue to contend with that, because not only do we use plutonium, which just passively decays, but I think they're looking at nuclear reactors to be able to transport us. Then we would get to Jupiter in 1 year instead of 5, and in Saturn in 2 years instead of 7. So that would really help us out a lot to be able, and then if we want to send people out into deep space, those reactors would help us travel faster. So, but what are the risks and what is the cost of that? We'll have to be careful. Thanks.
Back. 1, 2, 3, 4. Right. My question is sort of to the follow-up of his question is is the power unit on Dragonfly similar to the RTGs found on Voyager on the Voyager probes?
Yes, so the power source on Dragonfly is similar, I believe. It may not be identical to the ones on Voyager. I believe in both cases they use plutonium as the radioactive material. And Dragonfly's is an RTG, so if you can remember that Voyager's is an RTG, then that's true, yeah. Radioisotope thermoelectric generator. Ours is, I think, an MMRTG, so it's a different generation. So plutonium is kind of easy. It just sort of generates heat, and that helps to power up a battery. It's really similar. It might be identical to the ones on the Mars rovers, the 2 big ones right now. The 2 ones prior to that were solar panels, which is great, because nuclear power is wonderful. It can last for many years, but solar, as long as it works indefinitely. So Opportunity rover lasted 14 years, and it was designed for 90 days. So it worked really well, and that was great. But we can't use solar out at Titan. It's too far.
Thank you for the presentation. I was wondering, you were talking a lot about looking for evidence of life in the dunes, but are there pans, like methane pans, and would the probe or would the drone potentially be exploring or looking for life there as well?
Everyone gets to think about these answers before, right? It's good. I hope there are pans. I'm really trusting it because in many cases when I visit dunes, they always have pans in between them. Clay pan, salt pan. In my experience, that's a place where liquids can collect and very interesting things happen. So in some very large dunes in Arabia, in the United Arab Emirates, and this is where Star Wars episode, is it 1, was filmed, where Finn is standing at the top of the dune and looking down toward Jakku, and he's standing on another mega dune that exists in United Arab Emirates, and it's a really neat place. And those have beautiful salt pans in between and lots of biology in them, even though it's a hyper-arid desert. There's archaea and bacteria. So those are the places that I think will be the most fascinating. I really hope we find them.
I have a question, but this might seem like off topic, but I heard NASA is working on a device called a warp drive. And then there's the development of one called the Alcubierre drive. So one of the biggest hurdle is the gravitational creation. So I think I might have found a way on solving that problem.
I do hope you solve that problem. That would be awesome. That's good. So the best I know about the different drives you're talking about, the one that I'm aware of is just this idea of having nuclear power to help put us out into the solar system. There's another one that's an ion drive, and in this case you just ionize certain materials and then they sort of gently trickle out the back of your rocket, and that creates enough thrust to gently accelerate you. But if you keep accelerating, note that your velocity increases over time, and so you can really achieve some high speeds by doing that. If you want to stop at your destination, then you have to be conscious of halfway through and then turn around and slow yourself down before you reach the end. So we practiced that at some asteroid series in Vesta with the Dawn mission, and that worked really well, the ion drive, and was really efficient. So there are a number of different ideas for how we can get far out, and even more coming.
This is maybe a bit of a silly question, but in terms of communication, would the position of Titan behind Saturn impact communication? And also, I know with Jupiter, there's the satellite going around Juno. Is there something similar with Saturn that would help with the communication, or is it actually direct communication from the drone to the Earth?
So I'm pretty sure that we wouldn't ever be able to use Saturn to help us, though. Who's seen three-body problem? I'm just thinking that there's a little bit in there about it. I don't know. But I don't think we'll be trying that out. I think it's all just going to be this direct to Earth, and we'll rely on the three big radio telescopes. One's in Canberra, another one in Madrid, and the other one in California, Goldstone. And because think of where those are positioned, we've always got one looking at you wherever the Earth is in its rotation. When that is a problem is if the Earth is on the other side of the sun from Saturn, or vice versa, or if Titan is behind Saturn. And already those are planned out. I could go find the sheet that says, oh yeah, here's when there's a Saturn eclipse and we won't communicate with Earth for just a little bit. But it's not going to be more than a day or two, I think, in any case. And we can spend a lot of time on the ground, as we're mostly a lander. So, I don't know if that answered it.
Sorry if you touched on this before, but are there other identified depositional systems on Titan, or is it mainly just dune belts?
Thanks, I did not touch on those, but there are some river systems. And at the equator, where the deserts are, they appear to be mostly dry. And we sometimes see what's called alluvial fans popping out of those rivers and dotting the landscape. Not as many as we would expect. We're not sure why. Hopefully we can get some answers with Dragonfly. And then up near the poles, there are some beautiful river systems pouring into the lakes. And if you look and squint your eyes, you can see tiny little winding rivers. And so it's much more abundant in terms of river systems than Mars, but less abundant than Earth. It's somewhere in between. But we think there should be a richness of what we say fluvial systems that we'll see on Titan when we get there.
I have a question, like when is NASA going to start using plasma propulsion engines instead of using rocket or liquid thrusters?
Okay, so this is where I'm sort of out of my depth with the plasma systems. I'm not sure where that is in development, and but as with everything, usually they've got to test everything and try it out, and then they can start using it different places. But definitely we want to try different things so that we can improve and do the best we can, have more thrust with the rockets. As long as there's something better, then we'll use it, hopefully. Yeah. I don't know if I can answer that immediately, how much power the Dragonfly rover will use. But it uses enough that we've got to wait and charge the battery while it sits on the ground. So that's part of why we wait on the ground, is that we've got to wait for the plutonium to charge the battery.
Because the questions just keep on coming here. So we're going to do 2 more questions, and then we're going to officially call it a day, which means officially, which means unofficially you can still ask all your questions.
Thank you very much. I really enjoyed your presentation. I wanted to know, in the 3 years, should Dragonfly survive the entire time, how much land area are you hoping to cover?
I was originally hoping for, you know, we go from this dune, we'll fly, I don't know, 20 kilometers over to this dune. And as you go farther on in your engineering, the engineers say, well, we're going to go from this dune to the one right next to it. And then we're going to go to the one right next to that. And we're like, what? And so what I really would like is if, and it's possible, is to go from the middle of that landing ellipse up to the center of that impact crater. That's always been our original goal. So the engineers will always be more conservative in the way they describe what we can do. But also, you know, they're working within what they see. So that will be, oh man, what will that be? It could be, you know, 50, 100 kilometers that we can end up getting, you know, because if in each flight we do end up getting 5 kilometers, then eventually we can add those up and get there. So cross our fingers. That'd be great.
Man in the corner, mysterious.
Yes, I wanted to ask, in terms, just the same way we have comets passing the Earth and having the Schumann's resonance on Earth, is there anything replicated on Titan that could affect it in that type of resonance? The Schumann resonance, so effectively, if a comet is passing Earth, I think a few months ago, there was a comet passing either the sun or towards close to Earth's proximity, and the Schumann resonance tells us when there's going to be an earthquake, as an example. So it happens at, if my memory serves me correctly, at about 25 hertz at the lower Earth's frequency. And would that somewhat similar happen to the rover on Titan if there was a comet passing there as well?
I think because we have a seismometer, I remember there being a little bit of discussion of Schumann resonance, and that, but a comet, I don't know. I'm going to have to ask my friend Ralph Lorenz about that. He's going to know the answer immediately. He's, you know, knows everything Titan, and so he'll have a good sense of it. But wouldn't that be neat, you know, if you ended up having something pass close by? And I think just by virtue of having a body, an object, a spacecraft sitting on a surface, you make these discoveries you never even planned on before. And that's exactly what this friend of mine specializes in, is he's like, oh, this signal that we're getting is not from down here, but instead could be from a comet that just passed. And that would be a really neat frosting on the cake in many ways. Yeah, thank you. Everyone, very intelligent audience. Thank you for your incredible questions. So great.
Thank you, Jani. I think one thing that you did not mention now, but did mention before, so this mission, this machine, leaves 5th of July 2028, but it only lands 2034. So, yeah, that's why I'm dropping it now. So we will have to wait a couple of years before we actually do get some results. But I'm going to make it a must now. You can come up until 34, but you definitely have to come afterwards to tell us what happened. Thank you so much, everyone, for being here tonight. We do have a little bar. You're welcome to ask all your questions now. I'm going to create a space. And then I hope to see you very soon again.